Okay, today we want to talk about the shell method. The shell method is an alternative way to find the volume of a solid of revolution. We've already covered the disk method and the washer method, and the shell method is yet just another method that we use to find the volume. All right. Now, the first thing we want to do is just to avoid the problems. We want to remember, we want to use, when we're using the shell method, we want to use 2π instead of pi. Pi is used with the disk method and the washer method. The shell method uses 2π. And also be very careful about the boundaries and the axis. For instance, when you're using the shell method, you have to move about the opposite axis, right? And if you look closely at the formula, it will reflect that. But just to give you a quick example, here we have y equals x cubed, y is equal to 0, and x is equal to 2, and we're moving this about the y-axis. So we need to look at our boundaries that are on the x-axis, where if we were moving about the x-axis, we would look at our boundaries that are on the y-axis. So just be very careful. Like we said, the formula will reflect that, but it's just very easy to make the mistake. All right, so we want to be careful here. Okay, so the first thing we want to do, we want to draw the graph. All right. So just so we go have a decent representation of what we're trying to do. So first we have y is equal to x cubed. Now, if you remember, this is that curved graph everyone is kind of used to seeing. All right. Now we have y is equal to 0. Y is equal to 0, of course, is the horizontal line along the x-axis. And then we have x is equal to 2. All right. X is equal to 2. So, which is a vertical line. So what we're trying to do ultimately, we're trying to find this region, move it about the y-axis, and find the volume. All right. So now the first thing we want to do right here, once again, we want to come back to the formula. Now the formula, that's going to be V is equal to, let me enlarge it a bit. That's 2π. Then we have the integral, and then remember that is f times of f of x. So that's going to be f, and in this case, x cubed dx. Let me come back through and write everything the way we know we need to write it. Now, remember what we said earlier, that if we're moving about the y-axis, we need to look at our boundaries that are on the x-axis. And our boundaries here will be from 0 to 2. And our function, which is x and then x cubed. And now it really turns more so into an algebra problem. So we have to definitely be careful because we're past that level, but it's easy to make mistakes here if you're not careful. X times x cubed gives us x to the 4th power. Okay, and we still have our integral, which is going from 0 to 2. So nothing changes here. We just have to remember to simplify everything correctly. Okay, now, what's the antiderivative of x to the 4th? As we know, that's going to be x to the 5th over 5. Okay, so we have x to the 5th over 5, but we still gonna keep our 2 pi out in front. And we're evaluating this from 0 to 2. It takes a little while to write it, but we're okay. Now, as we continue moving forward, this is going to be what, 2 pi. And now we have 2 to the 5th power over 5 minus 0 to the 5th power over 5. Now, I'm not going to really put this in there because we know 0 times anything or to any power just simply yields this 0. Just to save a little time here. Okay, and now 2 to the 5th power is 32. So we have 32 to the over 5. And like we said, it goes a little bit slow because of the way I'm typing it. Write that in. But in the end, we have 2 pi times 32 over 5, which leaves us with 64 pi over 5. Or so now that's how we do this type of problem. Now, this could have also been done using the Washer method, right? But using the shell method in this particular problem was much, much more efficient, was a much cleaner, easier, faster problem. So that's why the shell method is very valuable for us.